Okay, I'm recording. Perfect. All right, guys. So, yeah, rational polynomial. Oh, I guess we're gonna start with the polynomial inequalities, right? So first, I'm gonna try to explain what I mean by inequality, right? And then, of course, we're gonna discuss how to solve polynomial and rational inequalities in general. Anyway, so first, so first question is, what's an inequality? Inequality. Well, first, when I say equality, of course, equality means that like two expressions are equal, right? Equality. It means that like we have two equal expressions. Two equal expressions. So for example, when you say x squared minus 2x equal to 0, okay? So this is an equality, right? Because of the equal, it's equal. So this is an equality, right? Because we have this equal to something, then there will be equality, right? Now, inequality, it means that we have like an expression which is larger or less than another expression, right? So we have an expression. Algebraic expression, which is actually not equal, but larger or less. Or less than another expression. So for example, first example, let's say you have x squared minus 2x, right? Larger or equal to, let's say, 4. Okay. So of course, this symbol here, this means larger or equal. Okay. And it's or equal because of this line here. You see this line right here? So that's why it's larger or equal. Okay, so I have one expression. So the expression on the left side, which is the x squared minus 2x, it's actually larger or equal than the second expression, which is just 4, right? So in this case, we have an inequality, right? This is an inequality. So this is, so we have this x squared minus 2x. It's not equal to 4, actually. It's, in some sense, it's unequal to 4. It's larger than or equal to 4. So this is inequality. Right? Or for, you can have x squared minus 2x strictly larger than 4. So this is, the symbol here means it's a strictly larger than 4. It cannot be equal to 4. It's a strictly larger than 4. Strictly larger. Okay, so here it cannot be equal to 4. Cannot be equal to 4. Okay, so we have larger or equal, or strictly larger, this is, of course, another example of inequality, right? This is, it's not equal. I mean, x squared minus 2x, it's not equal to 4, right? It's larger than 4. So this is, of course, this is an inequality. Right? And then the third possible inequality is, of course, less or equal or strictly less. So we can have, for example, x squared minus 2x. So if you reverse the inequality here, right? So this means, so this is less or equal. So this is less. So the x squared minus 2x, it's less or equal to 4. So it can be equal to 4. And again, this is, it's not equality, this is inequality, right? It's not equal, it's actually less or equal. So this is inequality. And finally, of course, last possible inequality is when it's strictly less. X squared minus 2x. And then we can have just strictly less, just less, right, than 4. So this is strictly less, which means, of course, it cannot be equal to 4. It has to be less, strictly less than 4, right? So, so it cannot be equal to 4. All right. So this is just like the different inequalities, right? So we have strictly larger, larger or equal, less or equal, or strictly less. All right. Now, how do we solve inequalities, right? So that's the next question. Question 2. So we're gonna start with polynomial inequalities. So how do we solve polynomial inequalities? So I'm gonna start with a very basic example. I'm gonna explain also what do I mean by solving, all right, inequalities, right? So how do we solve polynomial inequalities? So I'm going to show you the examples how to solve inequalities. I mean, polynomial inequalities, right? So I'm going to start with a very basic example, example 1. And of course, later things they're going to get more complicated. But first, let's start with a simple example, right? Let's say you want to solve. So you want to solve for x, of course. Solve for x minus 2. Let's say strictly larger than 0. All right. So this is an inequality, right? Because the x minus 2, it's not equal to 0. It's actually larger than 0, right? So it's an inequality, right? And then, so what do I mean by solving for x? This inequality. Well, I mean, we need to solve like the set of the values of x which satisfy this inequality, right? So for example, so if x, for example, if x is, let's say, 5, right? Then if you just replace x by 5, right? Then 5 minus 2, it's larger than 0, right? If you just replace your x, you know, this x by 5, then 5 minus 2, it's larger than 0. So it satisfies, so 5 minus 2 is larger than 0. So it satisfies this inequality, right? Because we need the x minus 2 to be larger than 0 or strictly larger than 0. And then yes, if your x is 5, then it satisfies this inequality, right? Because 5 minus 2 would be 3, which is larger than 0. So 5 here would be a possible solution for, would be a solution for this inequality, right? So 5 is one possible solution for this inequality, right? It's just one solution. Okay. But of course, I need to find all the values of x which satisfy this inequality, right? Not just one solution, but I need to find the set of solutions, right? So I can take, if you take another value of x, let's say 3. For example, if x is 3, then if you replace x by 3, of course, 3 minus 2 would be larger than 0. So then 3 satisfies this inequality, right? So it's larger than 0. So then x equal to 3 is also a solution. Okay, etc. So you need to find all possible solutions for this inequality, right? So all the possible values of x which satisfy this inequality, right? Of course, there are some values of x which don't satisfy this inequality, right? So for example, if you take, let's say x is equal to, if x is let's say -2, right? Then if you replace x by -2, you're gonna have like -2 minus 2, right? -2 minus 2, of course, it's -4. That's a negative number. So it's not larger than 0. So this is not true, right? Because -4, of course, it's not larger than 0. It's less than 0. So this value of x actually doesn't satisfy this inequality, right? Because when you subtract 2, of course, you get a number which is not larger than 0. It's actually less than 0. So x equal to -2, it's not a solution. So x equal to -2, it's not a solution. So the goal, of course, would be to find all possible values of x, find all possible values of x which satisfy, of course, the inequality. Okay, so that's what I mean by solving for x. So we need to find all possible values of x which satisfy the inequality, right? I mean, one solution is not enough, right? We have to find all possible solutions. All right, so now, so that's what I mean by solving the inequality, right? It's finding all possible values for f of x which satisfy the inequality. Now, how do we solve? Now, so let's see, how do we solve this? So how do we solve this x minus 2? Larger than 0. Well, this is like an equation, right? So all you have to do, guys, you're gonna solve for x. So you can just, for example, here, you can add +2 to both sides, right? And so then your x, of course, this -2 plus 2 cancel out. So then, so what you get is x on the left side strictly larger than +2, right? So what we are saying here is that the value of x has to be strictly larger than 2, right? So x here is strictly larger than 2. So to answer this question, what are the solutions of this inequality? Well, so the answer would be, so the solutions are, or the solution is, so for the answer, guys, of course, we need to use the interval notation. So because you don't have only one solution, of course, we have like you have a lot of solutions here. And the solutions here are given by any value, which is any value of x, which is larger than 2. So on your number line, you have your number line. Here is your x equal to 2. And what we are saying is that your x, which satisfies this inequality, must be larger than positive 2. So that will be the right side of positive 2. Okay. And of course, here, x cannot be equal to 2. It's strictly larger than 2, right? So then, of course, we use the parentheses at 2. We don't include the 2 because x is strictly larger than 2, right? So then, so the solution here, as you can see, it's from 2 excluded to positive infinity. So again, use the parentheses to exclude the solution. So 2 is excluded, right? So that will be the answer. And again, as I said, you need to use the interval notation to in the final answer. Any questions so far, guys? All right. Now, so this is, as I said, for just first example. And again, what we are saying here is that, so if you take
Pardon me, Professor, excuse me.
Yes.
This is like what we did earlier on in the semester with the notations this way?
With the domain. Yep.
Right. So if it was x is larger or equal, it would be brackets.
Yep.
Okay, great.
Yeah, absolutely. Yeah. Right. And again, what I'm saying here is that if you take any number or real number in this interval, for example, you take 10, 10 belongs to this interval. It's 10, it's between 2 and positive infinity, obviously, right? Then if you replace your x by 10, then 10 minus 2 would be positive. So it satisfies the inequality, right? So if you take any number in this interval to positive infinity, it would satisfy the inequality, right? Otherwise, if you take a number which is not in this interval, so if you take, let's say, so for example, if we take x, let's say negative 10, right? Negative 10, it's not in this interval, right? It's less than 2. Then because it's not in this interval, then it's not a solution. So it doesn't satisfy the inequality, right? So if x is negative 10, then, well, it's not a solution, right? Because it's not in the interval to positive infinity. All right. Now what I'm gonna do, this is a polynomial inequality because, this x minus 2, if you take just x minus 2, this is a polynomial, right, of degree 1, right? Because the highest power of x is 1. So this is a polynomial x minus 2. It's a polynomial of degree 1. Right? Because the highest power of x is 1. Now, let's say we have a polynomial of degree 2. So example number 2. Now I want to solve for x, of course. X minus 2 times x, let's say, plus 5. Okay. Let's say, again, larger than 0, strictly larger than 0. Okay. Of course, this dot here means multiplication, right? So it's x minus 2 times x plus 5 larger than 0. And again, the idea here is to find all possible values of x which satisfy this inequality. Now, so how do we solve such inequality? Well, so first step 1. So what I'm going to do, first step. So step 1, what I'm going to do, I'm going to solve we're gonna make it equal to 0 actually. So we're gonna solve x minus 2 times x plus 5 equal to 0. Okay. And then, so that's the first step. So let's first do this first step. As I said, so you make it equal to 0 in the first step. So in this case, of course, you have the product equal to 0. So we have this first factor. So this is like my first factor times my second factor equal to 0. All right. So what we do is, of course, then one of the, you don't have to distribute here, right? So you can just say, because it's a product of two factors of two numbers, then one of the numbers must be 0. So, or one of the factors must be 0. So either, x minus 2 is 0, or the x plus 5 is 0. Right? So then x minus 2 is 0. It means that x is positive 2. X plus 5 is 0. It means that x is negative 5. Okay. So as a first step, whenever you're going to solve actually an inequality, so first you make it equal to 0. Okay. And then, so this is the first step. Now in the second step, what we're going to do is we're going to do like we're going to make like a chart. So as a second step, number 2. So we're going to make a chart of signs. Okay. All right. So again, I'm going to use like my number line. And on this number line, I'm going to put my solutions, right? I got, remember, like in the previous example with just, with the x minus 2, just with the x minus 2, larger than 0, to answer the question, I use my number line, I put my 2, and then we said the x has to be larger than 2, right? Here, it's the same thing. So what I'm going to do, I'm going to use a number line. And on this number line, I'm going to put my solutions. So I have 2 and negative 5. So here's my negative 5. And here's my positive 2. Okay. And this is, of course, this is negative infinity. And here's positive infinity. Okay. Now, I have this x minus 2 times x plus 5. So what I'm going to do, I'm going to take the first factor, the x minus 2. So here's my first factor. Here's x minus 2. And I'm going to put, let's say, as so in the like first row, I'm going to put my x minus 2. So here's my x minus 2, let's say. Okay. Now, x minus 2, of course, the sign of x minus 2 depends on your x. So if if x is larger than 2, then x minus 2, of course, is going to be positive. If x is less than 2, then x minus 2 is going to be negative, right? So what I'm saying is, so if your x, if you take some number which is larger than 2, then x minus 2 is going to be positive, right? For example, if x is 4, okay, then 4 minus 2 is positive. Now, if you take a number less than 2, for example, if you take 0, or if you take I don't know, let's say negative 10, right? Then x minus 2 is going to be negative, right? So here, on the left side of 2, x minus 2 is going to be negative. Okay. So as you can see, guys, I mean, here on the right side, so this is like 2, right? This line, let's say this blue line represents 2. So on the right side of 2, x minus 2 is going to be positive. Now on the left side of 2, x minus 2 is going to be negative, right? I mean, just pick a number on the left side of 2, and you can see x minus 2 is going to be negative. And if you pick a number on the right side of 2, x minus 2 is going to be positive. Okay, so that's for x minus 2. On the right side of 2, it's positive. On the left side of 2, it's going to be negative, right? That's, again, that's for x minus 2. That's my first factor. Okay. And now, what about my second factor? Second factor, it's actually x plus 5. Right, that's my second factor. So I'm going to do the same thing for x plus 5. So I'm going to make like another row. So there's like a second row with the x plus 5. Right. And if you pick a number on the right side of -5, for example, if you pick 0 or if you pick 4, right? 0 plus 5 is going to be positive. 4 plus 5 is going to be positive, right? It's going to be 9, it's positive. So on the right side, so this, let's say this line here represents -5. Okay. So what I'm saying is that on the right side of -5, x plus 5 is going to be positive. So here it's going to be positive. So think of this yellow line, right? This yellow line represents like x equal to -5. And what I'm saying is, if you pick a number on the right side of -5, so this is the right side of the yellow line, right? That's this, the yellow line again represents the -5. So on the right side of -5, x plus 5 is going to be positive. And now if you pick a number on the left side of -5, for example, this -10 here, right? Then -10 plus 5, of course, is going to be -5, which is negative. So on the left side of -5, it's negative. X plus 5 is negative, right? It's the same thing like for x plus 2. X plus 2, you know, we have x minus 2. So we on the right side of +2, it's positive. X minus 2 is positive. And on the left side, remember this line here, this line represents, let's say, the x equal to 2. So on the right side of the blue line, it's positive. The x minus 2 is positive. And on the left side of x minus 2, it's negative. Right? So we did the same thing for x plus 5. So the yellow line represents the x equal to -5. On the right side, it's positive. And on the left side of this yellow line, which is supposed to represent -5, the x plus 5, it's, you know, this x plus 5 here, it's negative. Okay. Now, so this is like my two factors, the x minus 2, the x plus 5. So this chart gives you exactly the sign of your factor on the number line. Now, the last row, what I'm going to do in the last row, I'm going to multiply, right? Because remember, my inequality is my first factor, which is x minus 2, times my second factor, right? Larger or equal to 0. So I'm going to multiply the two factors now. So in the third row, what I'm going to do, I'm going to multiply the x minus 2 by the x plus 5. So this x minus 2 times x plus 5. Okay, so we need to multiply the two factors. Now, guys, what I'm saying is, so on this first interval, you see this interval from -infinity to -5? This is like my first interval. And on this first interval, the x minus 2, it's negative. That's what we are saying here. And the x plus 5, it's also negative, right? So on this green interval from -infinity to -5, the x minus 2, it's negative, and the x plus 5 is also negative. So when you multiply, because we need to multiply, right? It's my first factor times the second factor. So when you multiply negative by negative, you get positive. So here, I'm going to get positive. Again, this positive, it's because we multiply the signs, right? We multiply the negative, the first negative, the blue circle, with the second negative, which is in the yellow circle, right? This one here, right? So that will be, of course, positive. So that's why I got this positive, this green plus. So that's why it's positive. Now, next interval. So the next interval, it's like between -5 and +2, right? So I have this green, let's not green. Let's take red here. So from -5 to +2, that's like my second interval. Now, in this second interval, I have, so x minus 2, as you can see, x minus 2, it's negative. X plus 5, it's positive. So when you multiply, you have to multiply the signs in the column. So negative by positive, that will be negative. So the sign of the product of the two factors, negative by positive, would be negative. So this is, so here, it's going to be negative. Okay, so again, here we just multiply the signs. Multiply the signs. The negative times the positive. Okay. Now the last interval, it's like, it's like from +2 to positive infinity. This is like my third interval. Now, in this third interval, the x minus 2, as you can see here, in this third interval, x minus 2 is positive, and the x plus 5 is also positive. So when you multiply the two factors, the x minus 2 by the x plus 5, it's like you're multiplying a positive number by another positive number. So it's positive times positive. So then the answer, of course, would be positive. Right? So this is, it's positive times positive. So what we are saying here, guys, is that so we have this first interval, the green interval from -infinity, -5. So here, if we multiply the two factors, it's going to be positive. In the second interval from -5 to +2, this one right here. So when you multiply the two factors, we're going to have something which is negative. Then last interval, the blue one, from +2 to positive infinity. So when you multiply, we get something which is positive. Okay, so it's positive, negative, positive. And you know exactly when it's positive and when it's negative, right? Now, to answer this question, again, so this is like my step number 2. Now, so what we need to solve is, just to remind you, we need to solve x minus 2 times x plus 5 strictly larger than 0. Right? That's what we need to solve. So the question is, when the product of the two factors is, it's positive. Well, as you can see, let me just erase this. So in the first interval, from -infinity to -5, it's positive, right? And then in the second interval, of course, from -5 to +2, the red interval, it's actually negative. But then it's positive from +2 to positive infinity. So to answer this question, so this product of the two factors is going to be positive when x is in the first interval. That's from the -infinity and -5, right? So we have like -infinity -5, right? Now the question is, do we include the -5? Well, I mean, if x is -5, if your x here, it's -5, of course, -5 plus 5 will be 0. So the whole thing is going to be 0, right? So when x is, when x is -5, so remember this yellow line is supposed to represent like x equal to -5. So what I'm saying is when x is -5, the whole thing is going to be 0. So that's why you can put like a 0 on this yellow line just to say, well, when x is -5, the whole thing is going to be 0. And the same thing here for +2. So when x is +2, 2 minus 2, of course, is 0. So the whole thing is going to be 0, right? So yeah, and the inequality here, again, it's strictly larger than 0. So it cannot be equal to 0. So we need to exclude the -5, right? So I'm going to use parentheses for -5. Again, that's like my first interval. Now, second interval where this whole thing is positive is this one here, right? And that will be like from 2 to positive infinity, right? So the union, 2 to positive infinity. And the same thing here for 2. We have to exclude the +2 because it's strictly larger than 0. It cannot be equal to 0, right? Cannot be equal to 0. So we need to exclude the +2. So here both -5 and +2 are excluded. And I mean, you can check the answer. I mean, if you take any number in this interval, so we can check. Of course, this is a final answer, but if you want to check the answer, we can check the answer. You can take, for example, a number in this first interval from -infinity to -5. So for example, if x is -10, you can see that, so we're going to have like x is -10. So it's like -10 minus 2 times -10 plus 5, right? So this is like -12 times, -5. So the answer would be like +60, right? So the answer would be positive. Okay, so the inequality is true, right? So so -10, it's a solution, right? So and of course, if you take a number which is not in the answer here, for example, 0, right? I mean 0, it's not in the in these two intervals. You can see. So let's say if x is 0. If x is 0, then, if you do 0 minus 2 times 0 plus 5, right? This is like -2 times +5. And so the answer would be -10. Okay, so it's not larger than 0. This is negative. So it's not larger than 0. So this is not true, of course. Okay. So it's not a solution. 0, as you can see, 0 is not a solution. So the whole idea here, guys, is to make this chart of signs, right? So what we do again is just you study the sign of each factor, right? And then at the end, you're gonna multiply the signs, and then you can get the sign of the whole polynomial. All right, I mean, this is just a first example. Of course, we're going to do more examples. Is there any question, guys, before the next example?
Professor.
Yeah.
During the test or the exam or the homework, right? Is it compulsory for us to make a chat, or we could just do step 1 and then just jump into step 2 if we already have the answers?
I mean, how are you gonna get the answer? I mean, if you don't do the, you wanna use like a different method?
No, like rather than making a chat, right?
Chart.
You could use, you could be like, if X equals to -10. So minus
Oh,
10
like,
minus 2, something like that, rather than making the chat.
okay, you mean like you just take values like in each interval and see if the whole thing is positive or negative.
Yeah.
That's what you're saying. Yeah, that's another way to do it. I mean, if you yeah, I mean, yeah, of course. I mean, I don't mind. I mean, it's up to you, of course. I mean, the chart is not actually, um, it's not that hard. Let me do another example. But as I said, yeah, you can use just the number line and see where it's positive or negative. But the thing is, it's not, sometimes it's not convenient to use just the the number line, because sometimes you have like polynomials where you're gonna get like some large number. I don't know if you use like -10, but then you plug your -10 in your polynomial, and then sometimes you're gonna end up with very large numbers, or you're gonna stuck with the computations. I don't know, but yeah, I'm just this chart, I think it's like the most convenient way to to solve these inequalities. We'll see. But let me do another example. Example number 2. Example number 2. So in this example number 2, I'm gonna try to solve for x. Let's say you have x -1 times let's say x let's say +5 less or equal to 0. So we're gonna have the same steps, right? So it's again step 1, you make it equal to 0. So we need to solve like x -1 times x +5 equal to 0. That's the first step. So from this step, you can say, well, the answers, I mean, the solutions are, so either the x -1 is 0 again, or the x +5 is 0. So then x is +1, or x is -1. Sorry, x +5 is 0, so then x is -5, of course, right? So we got these two solutions. And then from that, from the step 1, can move to the second step. And in the second step, again, I'm gonna use my number line. So I'm gonna make this a chart. So on this number line, we have negative infinity, positive infinity. I'm gonna put my solutions. I have -5, I have +1. All right, I'm gonna put my first factor, which is x -1. So here's my x -1. And so again, this line here, this green line, is supposed to represent x equal to 1, right? Because that's where x is 1. On the right side, this line here, this blue line here, represents, of course, x equal to -5. Now, so for x -1, so if you are on the right side of +1, the x -1 is going to be positive, right? If you pick a number here on the right side of 1, for example, 10 -1 would be positive. And if you pick a number on the left of 1, x -1, of course, is going to be negative, right? If you pick 0, let's say here, pick 0, or pick -20, then x -1 would be negative. So here on the left, it would be negative. You see, so on the right side of your solution is going to be positive. On the left side of your solution, it's going to be negative, right? You don't have to, you don't have to compute anything, because, if my x is, let's say, I pick in -20 and I plug -20, well, here it's kind of easy, to compute if you replace x with -20. But imagine you have like 3 factors or 4. imagine you have like x minus 1 times x plus 5, x times x minus 6 times x, you have like 5 or 4 or 6 factors, right? So if you just plug some values of x and see if the sign is positive or negative, it's gonna take, you're gonna waste your time. It's gonna take a lot of time actually to, to compute the answer. But with this chart, you can just say, well, my first factor, it's x minus 1. Well, it's positive on the left side of 1. It's negative on the left side of 1. Next factor, it's x plus 5, right? And on the right side, so this line, this blue line represents, of course, -5. On the right side of -5, it's going to be positive. And on the left side, it's going to be negative. Okay. And then I can just multiply because that's what I need to solve. So I need to multiply x minus 1 by x plus 5. Right? And so all I have to do is just multiply the signs. I don't have to multiply numbers. I just multiply the signs. That's different. So like here in the first column, negative times negative, that's positive. Second column, it's negative times positive, so it's negative. Third column, everything is positive. So when you multiply, of course, that would be positive. So what I'm saying is, like, again, I have like 3 intervals. I have this first interval from negative infinity to -5. I have a second interval, right, from -5 to +1. And I have a third interval, like from 1 to +infinity. And yeah, and what I'm saying is, so on the first, in the first interval, my whole expression is going to be positive. In the second intervals, the whole expression is going to be negative, and then in the third interval is going to be the whole expression is going to be positive. So just to remind you, we need to solve x minus 5 times x plus 5 less or equal to 0, right? That's what we have to solve. That's the initial question, right? Less or equal to 0. So less, it's less than 0, right? When you are less than 0, it means it's negative, right? This is less or equal to 0. So it's like negative or 0, right? If you are less than 0, then you are negative, or of course, when you are equal to 0, you are just 0. So it's negative or 0. So where my whole expression is negative, well, it's going to be a negative, as you can see, in this second interval, right, from -5 to +1. So to answer this question, my polynomial or my expression is going to be negative from -5 to +1. And again, we have to ask ourselves if it can be equal to 0. And you can see here it's less or equal to 0, right? So it can be equal to 0. So we need to include the -5, because when your x is -5, the whole thing is going to be 0. And when x is +1, of course, the whole thing is going to be 0. So we need to include the -5 and +1. So we're going to use bracket for -5 and +1. Okay. And again, guys, the advantage of this chart is because when you have like more than 2 factors. So for example, next example, and you'll see also when we solve rational inequalities, right? You're gonna have like 4 or 5 solutions. So if you just plug numbers, you're gonna waste a lot of time. So let me show you another example. So example 3. Let's say I want to solve for x. Let's say phi x, -1 times, let's say x plus 2 times, let's say 5x, minus, let's say minus 10. Okay, strictly larger than 0. Okay. So here, like you have like 3 different factors, not just 2, and you have like, there's like 5 and 10. So if you x is like like a big number, I don't know if your x is 5 or 4 or wherever, you're gonna probably end up with like large numbers. But anyway, if you just so as a first step, all you need to do is just to make it equal to 0. So you solve, the 3x minus 1 times the x plus 2, and then the times the 5x minus 10 equal to 0, the whole thing equal to 0. Now we have like 3 factors, not just 2, right? We have 3 factors. So the same thing here, because you have a product of factors equal to 0. So one of the factors must be 0. So this is like my first factor. Now this is like my second factor. And this is like my third factor. Right? We have 3 factors. So then, either the 3x minus 1 is 0, or x plus 2 is 0, or the 5x minus 10 is 0. Right? So 3x minus 1 is 0. If you solve for x is going to be 1/3. X plus 2 is 0. If you solve for x, you're going to get x equal to -2. And 5x minus 10, if you solve for x, your x is going to be +2. Okay, so now like we have like 3 different solutions, not just 2, right? So it depends, of course, on the number of factors. Actually, it depends on the degree of the polynomial, right? This is, this is a polynomial because you multiply x by x by x 3 times, x by itself 3 times, right? So that would be x cubed. So this is a polynomial of degree 3, right? So that's why actually we have like 3 solutions. And you can imagine, like if you have a polynomial of degree 4 or 5, so if you have a polynomial of degree 5, you expect to have like 5 different solutions, etc. But anyway, so if you just use the second step, if you use the chart, you can just say, so if you make the chart in the second step, again, this is my number line, and my solutions. I'm going to put my solutions. Of course, you start with the smallest solution, which is -2. So here's my -2. My next solution is 1/3, and then we have +2. So you see here, guys, we have like how many intervals? So we have like first interval, and then there's like a second interval, and then there's like a third interval, and finally there's a fourth interval. So now we have like 4 different intervals, right? Now, if you just take, let's start with the first factor. First factor, first factor, it's px minus 1, right? That's my first factor. So, so I'm gonna put the x minus 1 here, right? So let's say this line represents -2. Here we have 1/3, and here we have the +2. All right. So px minus 1. The corresponding solution to px minus 1, of course, is 1/3, right? Px minus 1 equal to 0. That's when x is 1/3. So you take 1/3. You see, this line represents 1/3, right? And what you can say is on the right side of this line of this 1/3, the 3x minus 1 is going to be positive. So here it's going to be positive because you're on the right side of 1/3. Now, if you are on the left side of 1/3, it's going to be negative. right? So I don't have to plug any number. You see, if I plug a number, well, of course, I'm gonna plug like 4 different numbers, like a number for each interval, right, etc. I mean, I don't know, but I think this chart is it's very, very convenient. You'll see, even with the rational inequalities. Then next factor. So next row, next factor is x plus 2. Right, this is my next factor, x plus 2. So I'm gonna put x plus 2 here. So what's the corresponding solution to x plus 2 equal to 0? So x plus 2 equal to 0 means that x is negative 2. Right, so I'm gonna take the line where x is negative 2. So this is the line where x is negative 2, because if x is negative 2, of course x plus 2 is 0. And then on the right side of this negative 2, your factor is going to be positive, and on the left is going to be negative. You see? Next factor. Well, next factor is 5x minus 10. Right? And the corresponding solution to 5x minus 10 is positive 2. So like, I'm going to put my 5x minus 10 here. And as I said, corresponding solution to 5x minus 10 equal to 0, it's positive 2. So you take the line where it's positive 2, it's going to be positive on the right side of the positive 2, and going to be negative on the left. You see, and now I can just multiply. So you need to multiply, 3x minus 1 by times the x plus 2 by the 5x minus 10. So like in this first column or first interval from negative 2 to negative infinity to negative 2. So everything is negative, right? So it's like, so it's negative times negative, that would be positive. Then positive times negative, that would be negative. So the answer here, it's negative. The next column, it's negative times positive, that's negative, times another negative, that would be positive. So here it's positive. The third column, positive times positive, that's positive, times negative, that would be negative. And then finally, the last column here, that's positive, positive, positive. So everything is positive. So the answer would be positive. Right? And then, just to remind you, what was the inequality, right? The inequality was like the whole thing strictly larger than 0. So the inequality was like, what we had to solve is the x minus 1 times x plus 2 times 5x minus 10 larger than 0. So this is larger than 0, strictly larger than 0. It means it's positive, right? So this is larger than 0, strictly larger than 0. Right, larger than 0. So it has to be positive. The whole expression must be positive. Now, when it's positive, well, as you can see, it's positive here in the second interval and in the fourth interval. So the answer would be like, so first interval, it's from negative 2 to 1/3, right? Now, do we include the negative 2 and 1/3? Just remember, guys, I mean, if you are, so if your x is negative 2, like this green line, when you are on this green line, then the whole thing is going to be 0, right? Because if your x is negative 2 here, negative 2 plus 2 will be 0. So the whole thing is 0. Same thing for 1/3. So I'm going to just put 0 on this line, which represents 1/3, just to say, well, when x is 1/3, then the whole thing is going to be 0. And same thing here. I'm going to put a 0 on this yellow line, which represent the positive 2, just to say, well, if x is positive 2, the whole thing is going to be 0, right? So yeah, so if it's strictly larger than 0, it cannot be equal to 0. So we need to exclude the negative 2, of course, the 1/3, and then union, of course, there's a a second interval where it's positive, which is from 2 to positive infinity. So this is 2 positive infinity. Infinity, of course, is always excluded. And then we have to exclude the positive 2 because it's, again, it's strictly larger than 0, cannot be equal to 0. Yeah, I mean, yeah, that's how we solve polynomial inequalities.
Professor, I
in
have a
general.
question.
Yes, yeah, please.
Like for example, the first one, right? You were like 3x minus 1.
Mhm.
So you like, did you input minus, like, okay, minus 3, like 3 times minus 3 minus 1? Then you got negative 10. Then that's how you know that the answer is going to be negative. So how did you do it?
No, we don't have to do that. That's what I was saying to, yeah, you don't have to do that. So you have the x minus 1, right? And it's 0 when x is 1/3, right? Is 1/3 here, right? Then all you have to say, well, on the right side, it's going to be always positive. That's like a rule. So you have this factor, the x minus 1. You have your solution, which is 1/3. Then it's going to be always positive on the right side and negative like on the left side of the 1/3. You see what I'm saying?
Okay, so for the second one.
Second one, that's where when it's a 0, second one, x plus 2. It's 0 when x is negative 2, right?
Yeah.
Because if x is negative 2, then negative 2 plus 2 is going to be 0. So I'm going to take this line here. This is line supposed to represent negative 2. And yeah, as you can see, it's positive on the right of negative 2. The green line, again, the green line is supposed to represent negative 2. So it's going to be positive on the right side of negative 2 and then negative on the left side. You see? Next factor, 5x minus 10. So 5x minus 10, when it's 0. It's 0 when x is 2, right? 2 times 5, it's 10. 10 minus 10, of course, is 0. So this 2 here represents, so this yellow line, you see this yellow line? It represents the solution x equal to 2. And all I'm saying is, well, so it's going to be, you see, it's going to be positive on the right side of this yellow line and negative on the left. Make sense?
Yeah.
You see how it works? It's positive on the right, negative on the left side of the line, which represent the solution. So you don't have to plug anything. That's why, yeah, that's why this chart it can be very convenient. All right, guys. You know what? I'm gonna give you an exercise and see. I mean, if you have a trouble with this chart, again, it's if you have a different way to solve this inequalities, of course, you can use it in the test or in the exam. Of course, you have to show all your work. But as I said, this chart, once you know how it works, it's not that hard. I don't think it's very hard. All right, here's an exercise. Let's try to solve for x. Yeah, let's take 4x minus 5 times, let's say 12x minus 4 times, and then x plus 3, less or equal to 0. Okay, so this is a polynomial, of course, because when you distribute, right, it's a polynomial of degree 3, right? X times x times x, that would be x cubed. So this is a polynomial of degree 3. All right, so I'm going to give you a couple of minutes, guys, to solve this polynomial inequality.
Professor, is this the last topic for the semester?
No, this is the last topic for this chapter 2. So next, chapter 3, we're gonna discuss exponential and logarithmic functions, and then of course we keep the best for the end. The last chapter is the trig functions and trig inequalities or equations. Sorry. So as you can see, guys, I mean, the solutions, when you solve your polynomial, when you make it equal to 0, you solve your polynomial equal to 0. I mean, the solutions, they don't have to be, of course, whole numbers, right? Or integers. They can be fractions, you know, or decimals, etc. Oh, Matthew, you got the answer. Let's see. You're saying -3, 1/3. That's correct. 5. Let me see. 5/4. So negative, positive, negative. So here, so this is Matthew. I think you solved the larger than 0. So this is less, right? Less or equal to 0. I think you solve for that. That would be the answer for larger than 0. I mean, if it was larger than 0, that larger or equal to 0, then that would be the right answer. But here, as you can see, it's less or equal, so it's negative or 0, right? So this is like less than 0, so this is like negative or 0. But yep. Because you can see, I mean, if you can always check your answer, right? I mean, like if you take a number like in the second interval, like the 5/4 to the positive infinity. I mean, if you take 100, right? It's clear that if x is 100 here, everything's going to be positive, right? Like the first factor is going to be positive if x is 100. The second factor is going to be positive if x is 100, etc. Right? So, oh, okay. Oh, I see. Okay. You mean the same answer as Matthew? No, I don't think you did anything wrong. It's just because here so here we are looking for the solutions, such that the whole expression it's negative. It has to be negative, not positive. The answer, Matthew answer, it's when the whole expression is positive, not negative.
I don't understand, Professor, because I got 5/4, 1/3, and -3. Those are the 3 answers that I got.
No, I'm saying that you're talking about the first step.
No, the last step.
Last step, like so you mean your answer is the same as Matthew in the intervals?
Yeah, I got 5/4. Yeah, the same thing. It's
5/4.
just that we wrote it differently. Because he got positive infinity at the end. I got negative infinity at the beginning.
Yeah, that's the right answer. The negative infinity should be like negative. I think it should be negative infinity, -3, right? And then 1/3, 5/4, right? 5/4. That's it. What you got, right? That's the right answer.
I got negative infinity, -3, and 5/4, 1/3.
1/3. Just one thing. 1/3 is less than 5/4. 1/3 would be like less than 1, but 5/4 would be larger than 1. So yes, now Matthew answer is correct. Yeah, so Beijing, your answer is right. Yeah.
I just wrote down
should be 1/3 first before the 5/4. Excuse me, Matthew.
the sign I wrote down was the polynomial is larger than 0.
Larger, yeah. I knew. Yeah. All right. Does anyone need more time? Yeah, I mean, but again, you can see in this example. I mean, if you plug like numbers, it's gonna take a lot of time, I guess. But with the chart, you can just say, as I said, take a line of the solution. It's on the right is positive, on the left side of the line of the answer or the solution, it's negative. Yeah, so the first step, so you make it equal to 0, the whole thing equal to 0. And then, of course, so the first either the first factor is 0, or the second factor is 0, or the third factor is 0. Now, first factor is 0, then your x would be 5/4. The second factor is 0, then your x would be 1/3. So we have to reduce, of course, your answer, guys. I mean, so if you get like 4/12, then of course 4 and 12 both are divisible by 4, right? So then that will be 1/3. So you have to reduce your answer. Now the third factor, of course, x plus c is 0, then x is just negative. All right. So then next step, to the chart. Right, so here's my number line, and I'm gonna put my solutions. So first I'm gonna start with the negative number, which is -3. Then just be careful. I mean, so the 5/4, when you divide 5 by 4, of course, that would be 1 point something, right? And 1/3, I mean, 1 is less than 3, right? So if you divide 1 by 3, you're gonna get like 0.33, right? So 1/3 would be less, right? So it's 1/3 first, and then you have the 5/4. All right, so let's put my first factor. So what's my first factor? First factor is 4x minus 5. So I'm gonna put 4x minus 5 in the first row, right? So what's the corresponding solution to 4x minus 5 equal to 0? Well, we got 5/4. So this line here, you see this line? This is my x 5/4. And what I'm saying is on the right, so it's gonna be positive, and on the left, it's gonna be negative. Okay, you see? Now, next factor, it's 12x minus 4. So let me just write down here, second factor, it's 12x minus 4. Now, what's the corresponding solution to 12x minus 4 equal to 0? Well, we got, sorry, it's 1/3. So this line here, that's my 1/3. That's the solution of 12x minus 4. So then on the right, it's going to be on the right of this blue line, which represents 1/3, it's going to be positive. And on the left, it's going to be negative. Next factor, it's x plus c, right? So here's my x plus c. Next row. Oops. So x plus 3. Right? And what's the corresponding solution to x plus c equal to 0? It's -3. So here's my line representing x equal to -3. On the right of this red line is going to be positive, and on the left of this red line is going to be negative. You see? Now I'm going to just multiply the whole thing because that's what I'm interested in. So it's 4x minus 5, like times the 12x minus 4 times like the x plus 3. So I'm gonna just multiply the signs, right? I don't have to compute any number. So my first column, if you multiply the signs, it's negative times negative times another negative. So that will be negative. Second column, it's negative times negative, that would be positive times another positive. Then it's going to be positive. Third column, it's negative times positive, that's negative times positive, that's still negative. And then finally, of course, the last column, it's everything is positive. So here the answer is positive. Okay, now just be careful. You need to check what exactly you have to solve. So we need to solve. I mean, our initial inequality was 4x minus 5 times this 12x plus minus 4 times this x plus 3, right? And we said it has to be less or equal to 0. So this whole thing here has to be less or equal to 0. So less or equal to 0. So if you are less than 0, less or equal to 0. So if you are less than 0, it means it's negative. So it's negative or equal to 0. So it's negative or 0. So when my my whole polynomial is negative, well, you can see here it's going to be negative in this first interval. So that will be like from negative infinity to negative 3. And it's going to be negative in the third interval. This is like from 1/3 to the 5/4. Right? So, and yeah, so it's just the answer will be
Very pretty.
Even with short hair.
so it's negative infinity to
Doing your
negative
class now?
third.
Doing your class now?
No,
Uh,
it's not till 2.
Okay.
I'm just messing with this stuff again.
I think I have to mute someone. I'm sorry about that. Let's see. Oh, okay. Page. All right. So yeah, negative infinity, of course, is always excluded. Negative 3. Do we include the negative 3? Well, well, this line here represents negative 3 because it's negative 3 is supposed to be a solution. So it's going to be, the whole thing is going to be 0. The 1/3, it's also a solution. So then the whole thing is going to be 0. 5/4, it's also solution. So when x is a 5/4, the whole thing is also 0. So, and yeah, it can be equal to 0, right? The polynomial, our polynomial can be equal to 0. So we need to include the negative 3. Union. So the second interval, it's from 1/3 to 5/4, and both of them are solutions to our equation equal to 0. So we need to include both of them. Okay. Any question, guys? I mean, of course, you can pick, as I said, you can pick numbers, but I mean, it's not really, sometimes it's just, it's a waste of time if you pick numbers. You know, when you have your solution, you always know that you're like, your factor is going to be like positive on the right and negative on the left, right? But anyway, of course, if you prefer to pick numbers, that's up to you. Is there any question, guys?
Professor, I have a question.
Yes. Yeah, please.
Not regarding this, my bad, I'm sorry. For the test too, right? Are we still going to have a formula sheet too?
Oh, yeah, of course.
How about the final
test and the
exam?
final? Sorry?
Okay, so for the final exam, are you going to be the same person to be there or somebody?
Oh,
else?
yeah.
It's going to be you too?
Yeah, it's gonna be me, yeah, of course.
Oh, okay, all right.
Yeah, like for exactly like for the test, yeah.
Oh, okay, I got it.
Same thing, yeah. All right, guys. So then I guess we can. Well, I'm gonna talk a little bit about rational inequalities. So yeah. Now, what about rational? I mean, the idea is gonna be the same. Rational. So let's have an example. And let's say you want to solve x minus 2, x plus 5 over, let's say x minus 1 times, of course, this is multiplication, right? Times, let's say x plus 3, for example. Okay, then the whole thing strictly less than 0. Of course, this is now, it's a rational because it's a quotient of polynomials, right? And we have this is like a p of x, like in the top, and this is like q of x, right? So this is like p over q. This is exactly definition of a rational function, right? You have a quotient of polynomial functions. All right, so this is a rational, it's called a rational inequality because, of course, you have this rational function, right, on the left side. Now, yeah, I want to solve this. The same thing. What we're gonna do? I'm gonna have the same steps. It's just the same steps. So we solve step one. We need to solve both the top and the bottom. So both the top and the bottom equal to 0. So you make both of them equal to 0, right? The x minus 2. So we need to solve like the x minus 2 times the x plus 5 equal to 0, right? And we need to solve the x minus 1 times the x plus 3 equal to 0. Right, so here, instead of like just one polynomial, we're gonna have like two polynomials, right? One in the numerator and another polynomial in the denominator. But the idea again is just the same. It's just you need to solve both of them equal to 0. So like, so from the first, the numerator equal to 0, you're gonna have so either like the x minus 2 is 0, or the x plus 5 is 0. Right, and in the denominator, we're gonna have either the x minus 1 is 0, or the x plus 3 is 0. So here, of course, x would be 2, positive 2. Here, x would be negative 5. Right. So now, as you can see in this rational kind of simple rational function, we have like 4 different solutions, right? So and then x is like positive 1. And then x like it's negative 3, right? Now, next step, it's just I'm gonna do the same thing. So step number 2, I'm gonna make the chart. Again, here's my number line from negative infinity to positive, and then I'm gonna put my solutions. So the smallest solution, I think it's negative 5. Then we have like negative 3, and then we have like positive 1, and then we have like positive 2. Okay. And yeah, I'm gonna take my first factor. So like in the top, my first factor is, we have like, so in the top we have like 2 factors, right? You have the x minus 2, and then the x plus 5. And then in the denominator, we have like 2 factors, the x minus 1 and the x plus 3. So we have in total like four different factors, right? So first, let's start with the x minus 2. That's my first factor. So I'm gonna just put like x minus 2 in the first row. Okay, so when x minus 2 is 0? Well, x minus 2 is 0 if x, of course, is positive 2, right? X minus 2 is 0, it's when x is 2. So here's my x equal to 2, right? And let's say this line here represent my x equal to 2. So on the right side of this line, it's going to be positive. The x minus 2 is going to be positive. And on the left side of this red line, which represents x equal to 2, it's going to be negative. Okay. So if you pick a number, on the right side of 2, like 10 minus 2 is going to be positive. If you pick any number on the left, it's going to be negative. X minus 2 is going to be negative. Now, next factor, it's, let's say, it's the x plus 5, right? That's the next factor. It's this x plus 5. So here's my x plus 5, second row. Now, when x plus 5 is 0, x plus 5 is 0 when x is negative 5. So here's my x is negative 5, right? Now, on the right side, it's going to be positive, and on the left, it's going to be negative. All right. Next factor, well, we have x minus 1 in the denominator, right? Next factor, it's in the denominator. It's this x minus 1. So here's my x minus 1. So when x minus 1 is 0? Well, x minus 1 is 0 when x is positive 1. right? So here's my positive one. My x equal to positive 1. So this green line represents x equal to 1. On the right side of this green line is going to be positive, and on the left it's going to be negative. And the last factor in the denominator is x plus t. So here's my last factor, x plus t. And so when this is 0, well, x plus t is 0 when x is negative t. So here's the line x equal to negative 3. On the right side, it's positive. And on the left of this blue line, it's going to be negative. Right? And now, so we are done with the factors. So now what happens to the whole expression, right? So it's like x minus 2, x plus 5 over x minus 1, x plus 3. So the good thing, guys, here, I mean, when you multiply negative by negative, of course, negative by times negative would be positive. But that's the same thing when you divide, right? Negative over negative, it's also positive, right? So when you multiply the signs, I mean, it's the same thing as like when you divide the signs, right? So you multiply two negative signs, it will be positive, and when you divide two negative signs, of course, that will be also positive, right? So here, you don't really have to divide the signs. It's just multiply because it's the same thing. So all we have to do now in this column is just multiply the signs as usual. So I'm going to multiply negative by negative. That will be positive. Multiply by negative, that will be negative. And if you multiply again by negative, the whole thing is going to be positive. Okay, just multiply the signs here. You don't have to divide because it's going to be just the same thing. Multiply the signs. Right, we have 4 negative signs, so that will be positive. Next column, as you can see, next column is going to be just, let's see. So if you multiply negative by positive, that's negative, times another negative, that will be positive, times another negative, that will be negative. So here, it's negative. Third column, negative, positive, that's negative, times another negative, that will be positive, and times positive, so it's still positive. The fourth column, negative by positive, it's negative, negative, negative. So it's going to be negative. And then last column, of course, everything is positive. So when you multiply, of course, it's going to be just positive. So you see here, guys, I mean, if you plug numbers, I don't know. Well, here, the factors are kind of simple. It's just x minus 2, etc. But if you have like 10x minus 7 or, you know, and you plug numbers, then you're probably going to have, you know, I'm going to have a little bit of trouble. But with this chart, you know, you put your factors, you say, well, on the right side of my solution is positive, on the left side it's negative, then it's, you don't need to compute anything, right? All right, so and then, so what we have to solve, just remind you the original or the initial question. So we need our rational function to be strictly less than 0. Okay, strictly less than 0. It means, of course, it means it's negative, right? So we need to solve. So what we need to solve is x minus 2 times x plus 5, x minus 1, x plus 3, strictly less than 0. So this is strictly less than 0. So it's negative. It means it's negative. It has to be negative. My whole expression, my whole rational function, it's negative. So when it's negative, so you can see here in the chart, so it's negative in the second column, that it corresponds to the interval negative 5, negative 3. And it's also negative in the fourth column, and it corresponds to the interval 1, positive 2. So the answer here, so that'll be negative 5, negative 3, right? That's my first interval. Just be careful here, guys, because when you divide, because we are not allowed to divide by 0, right? So, so for example, do we include the -5? Well, I mean, of course, if your x is -5, you see here, if x is -5, the top is going to be 0, and then the whole thing is going to be 0. So I can put 0 here, right? If your x is +2, then the top is going to be 0, so the whole thing is going to be 0. Now, if your x is 1, right? If your x is equal to 1, the denominator is going to be 0, and we are not allowed to divide by 0. Okay, so you're not allowed to divide by 0, right? So your x cannot be equal to 1, all right? So we don't put the 0 here. The same for -3. We're not allowed to divide by 0, so x cannot be equal to -3 anyway. So for -5, so it has to be strictly less than 0, right? So -5, it's excluded because it has to be strictly less than 0. So that will be parentheses. -3, I mean, we don't really care if it's strictly less than 0 or less or equal to 0, because anyway, if x is -3, denominator is going to be 0, and we are not allowed to divide by 0. So this is -3 is always it's going to be always excluded anyway, because it's in the denominator. Union, second interval from 1 to 2, of course. 1, again, denominator is going to be 0, so 1 is going to be excluded anyway, but +2 is going to be excluded because it's strictly less than 0. So my x cannot be equal to 2. All right, so that would be the answer. So you see, there's no difference like with when we solve like polynomial inequalities with a rational. It's the same thing, right? You instead of course, in the rational case, you're gonna have like, two polynomials, one in the top and one in the denominator. And the same step 1, it's always the same. You have to solve both the denominator and numerator equal to 0, right? And then step 2, make the chart. And again, you don't have to divide, just multiply the signs and that's it. Same thing like for polynomials. All right, guys, there's only 1 minute left, right? So I guess on Wednesday, we're gonna practice a little bit, like at least like for rational inequalities, right? So we're gonna have probably 1 or 2 more exercises about this section, and then we can move to the next chapter. All right, thank you for listening, everyone, and I will see you in person this Wednesday.
Thank you,
Thank you,
Professor.
Joe.
Thank you. Have a good day.